All right, eighth grade students. So today we're going to go ahead and start with our first sections of notes, um, which is on 1-1, which is all about the difference between rational and irrational numbers. So a rational number can be written as a ratio. So if you look at the word rational numbers, the first few letters do spell ratio. So a rational number is a number that can be written as a ratio, okay, of two integers. So of two integers. Okay, so a few examples might be 6. Well, 6 can be written as 6 over 1, right? 12 over 2, 18 over 3. All right, a few more examples of a rational number could be 1.7 repeating, all right? Because that can be written as 1 and 7/9. Anything that has 9 on the denominator is a repeating number. Another example might be -2 and 3/4. Okay, we can write that as a fraction. That as a fraction is -11/4. So a rational number can be written as a ratio of two integers. There are some examples, all right? Which means an irrational number, all right, is a number that cannot be written as a ratio. So can not be written as a ratio. Okay, a few examples would be a number such as 2.69372 goes on forever, right? It never repeats. The number just goes on forever, never repeats, has no repeating numbers in there, no pattern. Number that can not be written as a ratio. Another example would be the square root of 7. Okay, again, if you type the square root of 7 into the calculator, you're going to end up getting this number here, 2.69372. Another number that's an irrational number is pi. All right, if you think about pi, we usually use the number to approximate pi as 3.14. But really, if you Google pi and what pi is equal to, it goes on forever and ever and ever. All right, so that is an irrational number. So here's the really cool thing about rational and irrational numbers. The sum of rationals is always a rational number, which makes sense. If you can write a number as a ratio and you're adding two ratios together, okay, it's going to be a rational number. Same thing with product or multiplying. The product of rationals is rational. The sum of a rational and irrational is always going to be irrational, right? So anytime you're adding something that you can write as a ratio and something that you can't write as a ratio, then it's going to become an irrational number. And then the product of a rational and irrational is always going to be irrational. Unless, what do you think a case might be, okay, where you have an irrational number and you're multiplying it by a rational number? What do you think the answer would be to this question here? What case do you think would be our special case? All right. Down here is a nice little graph, a visual for you guys to kind of see what we're talking about to classify numbers. So the first thing you're going to see is the natural numbers. Natural numbers are the numbers you use to count with. So when I think about this, I'm like, okay, well, when I was in first grade, second grade, what numbers do you count with? Well, 1, 2, 3, 4, right? We never start with 0. So a whole number, if you think about a whole, that's going to use 0 as well. So you started using those when you were maybe like in third or fourth grade, learning about that number line. That 0 technically is a number, okay? Then you moved into integers. Well, integers, okay, includes natural numbers and whole numbers, but now it's starting to use those negative numbers on the number line as well. Okay, we scroll down more. Rational numbers include fractions and decimals. Okay, and then we have irrational, which we went over above. Real numbers are all rational and irrational numbers. So everything, both rational and irrational, is a real number. Okay, and when you get to good old high school, in Algebra 2, you're going to learn about these imaginary and complex numbers. Yes, there's something called an imaginary number, and yes, that's a real thing. You guys will go over that in high school. Okay, so down below, let's go over a few examples of ordering rational and irrational numbers from least to greatest. So when you're doing this, I always like to convert fractions into decimals, compare them. So when I do this, 1/3, well, I know because I have this memorized that it's 0.3 repeating, okay? Square root of 14, well, if I go down here, and let's find my calculator. Okay, and if I press this button right here, and then I press the square root of 14 and enter, okay, oh, not 14, square root of 14, it's 3.74, okay, I'll just say 3.74 for rounding for now, right? So this here is going to be 3.74, and then we have 3 5/10. So least to greatest, well, I know 1/3 is the least. Notice how I'm putting it back in the original format that they give me. 1/3. After that, we have 3 5/10. Okay, and then after that, I have the square root of 14. We'll be getting into square roots a lot later this year as well. It's going to be fun. Next, the square root of 1/4. Well, a way to look at this, guys, is say, okay, well, the square root of 1 over the square root of 4. I know the square root of 1 is 1. The square root of 4 is 2. So 1/2 as a decimal is 5/10. So from least to greatest, well, it looks like I have a negative in here. So from least to greatest, I'll have -4. All right. I have 0.16 repeating, right? So that would be 0.16. Then my greatest in there is the square root of 1/4. Go ahead and do number 3 on your own. Tomorrow I'm going to check number 3 and make sure you have your notes filled out. Go ahead and complete that on your own and you are done.